Hello everyone, welcome to section 6.2 on the trigonometry of right triangles. Let's go ahead and get started. So a right triangle is a triangle that has a 90-degree angle. We use this box here to say that this angle here is 90 degrees. Now the longest side of a triangle, of a right triangle, is always called the hypotenuse, and the other two sides are sometimes called the legs. Now we actually give the legs of a right triangle different names depending on where we're standing. For right now, let's say we're standing at angle theta. So here we are standing, happy of course. The longest side of a triangle will always be called the hypotenuse. Now if you're standing here and we're looking straight ahead, this would be the wall you're staring at. We always call this side here the opposite. Now the other leg we call the adjacent. The word adjacent means to touch. It's the other side that's not the hypotenuse that's touching the angle. Now these names get changed if we're standing at a different location. So let's imagine for a second I draw this same triangle. Let's call this angle here, how about we call it phi, the Greek letter phi? And let's say that we're instead standing right here. So the longest side of the triangle will still always be the hypotenuse. But now if I'm standing here, this is the wall I'd be staring at. We call this the opposite side. And the other side that's touching the angle was the adjacent side. So now that we have this vocabulary down, what we want to do is we want to actually talk about the 6 trig functions. What the six trig functions are is they, depending on where we're standing, they relate the ratio of the sides of the triangle. Okay. So here's our right triangle. Let's say we're standing at the angle theta. This will be the hypotenuse. This will be the opposite, and this will be the adjacent. Now the first 3 trig functions, the most important ones, are sine, cosine, and tangent. Now to remember the definitions of these trig functions, there's a common memorization trick that's called SOHCAHTOA. SOHCAHTOA. So if we're finding the 6 trig functions of theta, means we're standing here, sine of theta is defined to be opposite over hypotenuse. Opposite over hypotenuse. The cosine of theta is defined to be adjacent over hypotenuse. And the tangent of theta, abbreviated TAN, is defined to be opposite over adjacent. Now the other 3 trig functions are the reciprocals of these. So the reciprocal of sine is what we define to be cosecant, and we abbreviate that CSC. The cosecant of theta is the reciprocal of sine. It's 1 over sine. So that'll be hypotenuse over opposite. The reciprocal of cosine is what we call secant of theta, abbreviated SEC of theta. It's defined to be 1 over cosine of theta. So that'll be hypotenuse over adjacent. And the reciprocal of tangent is what we call cotangent, abbreviated COT. The cotangent of theta is defined to be 1 over tan of theta, which will be adjacent over opposite. So these are the definitions of the six trig functions. Now, for whatever reason, I'm awful at spelling. And when I hear SOHCAHTOA, it's very common. You'll hear everyone talking about trigonometry will always be talking about SOHCAHTOA. But when I'm spelling SOHCAHTOA, for whatever reason in my head, when I hear the word so, I don't know why, but I don't know if that's spelled S-O-H or S-O-A, so there's an alternative way I think about this. I guess a PG-13 version. You can think of this as some old hippie caught another hippie tripping on acid. And that's how I memorize it. I never get the spelling wrong now. Another thing to comment on is something that I hate, but I wasn't the one who made up these definitions of the functions or named it, or came up with their names. But it always drove me nuts when I was studying this, that the reciprocal of sine, cosecant, it started with a C. The reciprocal of cosine started with an S. I wish that the reciprocal of sine was secant, and I wish the reciprocal of cosine was cosecant. It would help me memorize it, but it's the opposite, and I have to remember it that way. The reciprocal of sine is cosecant. The reciprocal of cosine is secant. Okay, let's go ahead and do an example. Let's find the six trig functions of theta for the following. Okay. Go ahead and pause the video and see if you can complete this problem on your own. Okay. So the main problem so far is that I don't know the length of the hypotenuse, so I can't find all the six trig functions. So our first job will be to try to figure out the length of the hypotenuse. We'll call it C. And to do this, we're going to use the Pythagorean theorem. Now, if you've never seen the Pythagorean theorem before, or you'd like to see a proof of it, check out my video on the proof of the Pythagorean theorem. But what the Pythagorean theorem here says it says that the sum of the squares of the legs of a right triangle is equal to the square of the hypotenuse. So it says that a squared plus b squared is equal to c squared. The sum of the square of the legs of a right triangle is equal to the square of the hypotenuse. So using that here, we'll have that c squared is going to be equal to 8 squared plus 15 squared. We can solve for c by taking the square root of both sides. So c will be the square root of 8 squared plus 15 squared. Notice here I did not do a plus or minus. The reason for that is because c is a physical length, and lengths are positive. So this turns out to be 17. So we'll replace the hypotenuse with 17. So now we're ready to find all the six trig functions. So let's go ahead and write down SOHCAHTOA. So we'll have that sine of theta. So we're standing here. Sine of theta is defined to be opposite over hypotenuse, 15/17. The cosine of theta. Cosine is defined as adjacent over hypotenuse, so that'll be 8/17. The tangent of theta is defined to be opposite over adjacent, so that'll be 15/8. And the other three will be the reciprocals. So the reciprocal of sine is defined as cosecant of theta, which will be 17/15. The reciprocal of cosine is what we call secant. So that'll be 17/8. And the reciprocal of tangent is what we call cotangent. And that'll be 8 over 15. And there you have it, the 6 trig functions of theta. Let's do a slightly different problem. Let's say we want to find all 6 trig functions, not of theta, but how about phi? This is the Greek letter phi. Oftentimes for angles we use Greek letters. Sometimes we'll use theta, phi is a common one, this kind of W is omega. These are, I would say, the most common Greek letters we use for angles. You actually sometimes might see alpha and beta. Okay, so let's say phi is right here. What I want you to do is find all 6 trig functions of phi. So go ahead and pause the video and try this on your own. Okay, so if I'm trying to find the 6 trig functions of phi, what that means is that we're standing here. So now, this will now be my opposite side, and this will be my adjacent side. So we have that sine of phi will be opposite over hypotenuse, so that'll now be 8/17. The cosine of phi is adjacent over hypotenuse, so that'll be 15/17. And the tangent of phi will be opposite over adjacent, so that'll be 8 over 15. Now for the other 3, we'll just reciprocate these. So the reciprocal of sine is cosecant. So the cosecant of phi will be 17/8. The reciprocal of cosine is secant of phi. So that'll be 17 over 15. And the reciprocal of tangent, cotangent. That'll be 15/8. And there we have it, the 6 trig functions of phi. Okay, this might be a good time to pause and try some of the wall map exercises. We'll see you in the next video.